Hello and welcome to Calc, oh dear, that's better, Lesson 8. Today we are going to talk about your favorites, Pythagorean identities, and all of your other trig identities which you are totally responsible for from pre-calculus. So let's get started. Please remember, and you should be taking notes on this, sine squared of an angle plus cosine squared of an angle equals 1. We can also rewrite these because we know cosine squared is 1 minus sine squared. So we have 2, oh dear, cosine squared theta minus, I forgot my Pythagorean identities. Oh no. All right, so we can rewrite this one in two different ways before I start plugging things in. I can solve for sine squared theta, which is 1 minus cosine squared, and cosine squared, which is 1 minus sine squared. So these two come from this one. Now, if I divide the original by sine squared, I get 3 more. So sine squared divided by sine squared is 1. Cosine divided by sine is cotangent. 1 divided by sine squared is cosecant. And I can rewrite this one. So this is 1 equals cosecant minus cotangent. And also cotangent is cosecant minus 1. If I divide this by cosine squared, then I get another set of identities. That would be tangent squared plus 1 equals secant squared. And I can rewrite this one by solving for tangent. Oh dear. And by solving for 1. Woo! So, we have all of those. Moving on, like a cow would, moo. And hopefully you can see all of those. Next, we're going to talk about identities that involve a negative angle. So we have sine, cosine, and tangent. If you know sine and cosine, you can find the rest. So we have cosecant. We have secant. There we go. And we have cotangent. So sine of negative angle is negative sine of that angle. Cosine is just cosine of that angle. Sine is an odd function, so it works like that. Cosine is an even function, so it works like that. Now, tangent is sine over cosine, so I expect negative tangent. And these are going to follow suit with the originals. Alrighty. Now, let's talk about all the rest of our trigonometric identities. So, they're going to have you do proofs, just like you did in pre-calculus. Yeah, I'll move this guy over. So let's show that this is true. We have cosine squared x plus 4 plus sine squared x over 5 secant squared negative x equals cosine squared x. So how do we do a proof? Well, you start with the most complicated side. That would be our left side. And then you look for an identity. So first step, we're going to copy that down so that our proof may be complete. Okay, first step, I'm going to look for identities. I know that sine squared plus cosine squared is 1 from way over here. So I'll use that identity. I also know that secant of negative x, a minus just goes away. So now I'm going to rewrite that, again, showing all of my work painfully because I'm proving something. If I wasn't proving it, if I just wanted to know the answer is cosine squared, but I'm showing how I got there. So sine squared plus cosine squared is 1 plus 4. And we know that secant of a negative is just that thing. Okay, from here, I am going to do algebra, cancel if possible, and then if I have nothing else that I could possibly do, I'm going to convert back to sines and cosines. So secant is 1 over cosine. Now I'm going to do algebra again, look for identities, and I get cosine squared, which is exactly what I expected, which is the right side. I'm going to put a little box to indicate that I've completed my proof. Okay? Again, the steps are, you want to try and use an identity, then do algebra. Then, after you've repeated this as many times as you possibly can, you are going to convert everything to sines and cosines, like we did here. And then go back again, evaluate, and then finally you should end up with the left side equals the right side. So if you wrote this out completely, you'll have the left side, you'll have a bunch of work, you'll have the right side, and that equals right side. Now, let's add more identities to our list of identities. I kind of want to scare the other classes, so I'm actually going to write them right here. Not scare them, but strongly encourage them to take calculus. How about that? So, we have cofunctions, which is when you have sine of 90 minus the angle, cosine of 90 minus the angle, tangent 90 minus the angle, cosecant 90 minus the angle. This is so fun. Secant 90 minus the angle. That's weird. And cotangent 90 minus the angle. So anytime you have a function, a trig function of 90 minus the angle, these are called cofunctions. So sine becomes cosine. Cosine becomes sine. No pluses or minuses, just the other cofunction. Or you remove the co. All right, last part of our lesson is similar triangles. So this should be a review. I'm going to pick the most challenging one because we've probably forgotten how to do it. It's been so long. And that is this one here. So it's a right triangle split into 3 similar triangles. So we have y, x, we have the number 3, 9, and z. Now remember, the trick with this is that if we name the angles, if we have angle 2 and a right angle, then this one must, or angle 1 and a right angle, this one must be angle 2. If we have angle 2 and a right angle, this one must be angle 1. So I can draw out 3 triangles. Let's start with the left one. And the idea is to get them all drawn facing the same direction with the angles in the same spot. Yes, you must draw them out so that you have the best chance of getting this correct. Now, I'm going to do this triangle to the right. I know the orange is a little hard to see, so I apologize in advance. Okay, between angle 1 and the right angle is x. Between the right angle and angle 2 is 9. And between angle 1 and 2 is z. So you have to kind of rotate it around. Then our biggest triangle, the whole thing, again, I'm going to ask, what is between the right angle and angle 1? That looks like y. What's between the right angle and angle 2? That's z. What's this one? It's 12. From there, I can do similar triangles. So I'm going to pick, if I want to solve for y, I'm going to pick the 2 triangles with y in them. So y over 12 is 3 over y. So it looks like y squared equals 36, y equals 6. Whoa, they gave you nice numbers. That's kind. If I'm solving for x, I'm going to pick the 2 triangles with x. X over 9 equals 3 over x. X squared equals 27. X equals 3 square root of 3. That's a little uglier. That's better. And then the two triangles with z, z over 12 is 9 over z. If I multiply those, z squared is 96. Z equals the square root of, let's do 3 times 2 is 6, square root of 3. Is that actually right? It is. So that is problem set 8. Enjoy.